Welcome to your Section 5 review. In order for this to be useful and successful for you, you're going to need the following items. You will need your Section 5 CAMI journal. You will need your green sheet opened up to Section 5, page 6. We will be completing the Chem to Go Part 3 together. In order to complete these, you will need a pencil, a calculator, and scrap paper because we will be doing a practice slope problem as well. All right, so we really need to emphasize that nothing on elements or metals is going to be on the Section 5 quiz. It will strictly be Section 5 material, so that would be mass, volume, and density, as well as slope. All right, so without further ado, let's get started. We're going to start with our CAMI journal and the essential questions. There we go. Alrighty, so the video we had linked for the essential questions is from Indiana Jones Raiders of the Lost Ark. Let's take a quick look. Alrighty, so his goal here is to steal this golden statue, right, from this tomb, and he's trying to, right, do something with that bag of sand. Interesting. So that he can swap the two out. Right, so we really want to know, why was he taking a little bit of sand out there? What did he think would happen? Right? And what properties of his two materials was he trying to take advantage of? Alrighty. And like all movies go, the hero survives, as usual. Alright, so for our essential questions, so you should have your CAMI journal open to the last part. Alright, so on the in the macro, what did Indiana Jones do before swapping the statue with the sandbag, and why did he do this? Right, so we saw Indiana Jones put his hand inside the bag and take a little bit of sand out. What he was trying to do was he was trying to reduce the mass of the sand inside of that bag, because he needed the mass to be the same as the mass of the golden statue. For the nano, what is the difference between how the particles were arranged in the gold statue and how they were arranged in the sandbag? So the main question here is, which one of those objects, either the sandbag or the statue, is more dense? Right, and hopefully you said that the golden statue is more dense. So when we're looking at how the particles are arranged, all right, because the statue is more dense, the particles will be closer together and there'll be more packed in there. All right, so I want you to draw a picture on your CAMI journal depicting, right, at the particle level what the statue and the sand look like. Remember, the statue should be denser and have more particles, and more particles closely packed together. All right. At this point, we're going to be hopping into our Chem to Go Part 3, Section 5. Right, so you should be looking for these same problems. Right? If you already have these done, awesome. That means you're ahead of schedule. You can check your work with me. If not, we're going to work through them together. All right. So number 1 says, find the density of a liquid if 8.0 milliliters of the liquid has a mass of 10.0 grams. Right, I like to start all of these out with a T-chart. And I put my known information on the left. So the liquid has a volume, and I will write that as V, of 8.0 milliliters. And it has a mass of 10 grams. We are trying to find the density. Alright, so what is our formula that we can use to solve these? Well, it is D equals M over V. And in this situation, we're trying to solve for D, and I already have D by itself on one side of the equal sign. So I don't need to rearrange my formula in order to solve for my answer. I can just plug my numbers in. I have 10.0 grams divided by 8.0 milliliters. Right, so what would our units be for this? and then what would our numerical answer be? So our final answer would be 1.25 grams per milliliter. Our units, right, G divided by ml is an acceptable unit for density, and 10 divided by 8 gets me 1.25. Your answer will not be fully correct if you do not have a number and a unit attached to it. All right, let's take a look at the second one here. All right, so we'll start with another T-chart, and our given information: a plastic ball with a volume of 20 centimeters cubed has a mass of 15 grams. What is the density of the plastic ball? So first we have a volume of 20 centimeters cubed, and we have a mass of 15 grams. We are trying to find the density. Right? This is another one that is fairly simple compared to some of the other ones we will do. Right? So our formula would be D equals M over V. All right, I don't need to rearrange it because I'm looking for density, and I have density by itself on one side of the equal sign. So now I can plug in my numbers. For mass, I have 15 grams. And for volume, I have 20 centimeters cubed. All right, so first, what would be the units of this answer? Good, should be grams per centimeter cubed. And we have 15 divided by 20, which should get me 0.75 grams per centimeter cubed as my answer. Question 2a says, would this plastic ball float in gasoline if the density of gasoline is 0.70 grams per centimeter cubed? So we're looking at these two numbers that I have underlined. Whichever one is more dense or has a greater number for its density is going to sink. Whichever one has a lower number for its density is going to float. So we can see that gasoline has a lower density, so no, the plastic ball will not float, right? Because, right, the plastic ball is denser than the gasoline. All right, let's move it up. We're going to make it a little bit more difficult. So start with our T-chart like always. If the density of ethyl alcohol is 0.80 grams per milliliter, how many grams would 15.0 milliliters of ethyl alcohol be? All right, so it gave us our density. Density equals 0.80 grams per milliliter. All right, we're trying to find how many grams, and grams tells us mass. Right? Now 15.0 milliliters, milliliter is a unit of volume, so 15.0 milliliters would fit for volume, and remember we're trying to find the mass. Alrighty, so our formula, like always, we'll start with D equals M over V, and we need to solve for M. So how can I move this V over to the other side of the equation? So right now we have M divided by D. In order to move V over, we need to do the opposite. So the opposite of division would be multiplication. If we multiply the right side by V, we must also multiply the left side by V. On the right, we now have M times V divided by V, and our V's would cancel out, giving me a new formula of mass equals volume times density. All right, so now we can plug in our numbers and our values since we have mass by itself on one side of the equal sign. So my volume of 15.0 milliliters times my density of 0.80 grams per milliliter. Now before I type anything in my calculator, I need to decide what my units are going to be. Right, so we have a milliliter times a gram divided by a milliliter. The milliliters will cancel out and leave us just with grams as our unit. Now does that make sense? It does, because gram is an acceptable unit for mass. Alrighty. So now we can plug our number into the calculator. So we do 15 times 0.8. And you should get 12 grams. All right, we got one more to get through before we hop into a slope practice problem. So how many milliliters of vegetable oil is needed, sorry about that, to obtain 9.0 grams of vegetable oil? The density of vegetable oil is 0.90 grams per milliliter. So we'll start with our T-chart. So we're trying to find how many milliliters. That would be volume. So volume is what we don't know. And we have 9.0 grams of vegetable oil. That would be our mass. And it tells us the density of vegetable oil is 0.90 grams per milliliter. Alrighty. Our formula that we will use is the same as always, D equals M divided by V. And we now need to solve for volume. Right? This is the most difficult of the variables to solve for. It will take us 2 steps. So first things first, we want to get rid of this fraction. Right? I don't have a way to move M over to the other side. All right? So what I can do is multiply both sides by V, just like we did above, and the V's on the right will cancel out, giving us V times D equals M. Now in order to get V by itself, I now am multiplying V times D. I need to do the opposite of that. So I will divide this side by D, and if I do it to this side, I need to do it to the other. All right. The D's on the left cancel out, giving me a new formula of volume equals mass divided by density. All right. If you do not understand how this works, right, you need to contact us like immediately. Okay, this is something that you're going to have to do on your quiz. Now we can plug in our numbers. We have mass of 9.0 grams divided by my density of 0.90 grams per milliliter. All right. In this situation, my grams would cancel out, leave me just with the unit of milliliters. And that makes sense because a milliliter is an acceptable unit for volume. And now I would do 9.0 divided by 0.9, and I got 10 milliliters as my volume. All right, so hopefully at this point you are very comfortable with density problems. Unfortunately, this video ran a little long, so we're going to have a second video, quick one, going through how we find the slope.